Hello, I'm Jenny Sanders, and this is Lab 9. For this lab, we are examining the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. This system consists of the mass, earth, and the spring. The result of this lab is that we found there's a change in the spring potential energy, which results as 0.00438. So the first thing that we did was we looked at Tracker. We uploaded the video of the mass and the spring. We can see that the axis right here, this is the x coordinate, y coordinate. The spring is moving in the negative y direction. And you can see once I play it, also the calibration stick is 0.7 meters long. And you can see once I start the video, I plotted different points during the time interval. And the total time is going to be 9.4 over here. So this gives me a list of x and y values, and I'm going to set that up into a CSV file, which is going to be going into my code, so I can compare it to my computational model. So yeah, that's my tracker information. So in my computational model, I set everything up. The mass equals 0.402. I set the position of the ball as exactly where he had just lifted, he had about to pull off the spring. So it is at negative 0.124 in the x direction and then negative 0.63 in the y direction. I uploaded the CSV file. The spring was the same, so the spring constant is still the same. The original strength is 0.139, stretch is 0.139. With this system, I have a gravitational potential energy, which is the mass times gravity times the change in y. And so that is the gravitational potential energy. This is the initial. With this, I'm going to go to one of my what-if questions, my second one. It says, with your new choice of system, determine the work done by the surroundings. Is the energy principle satisfied? So since the change in energy is equal to 0, the work is equal to 0. So that means that there is now this new thing called spring potential energy that we have to put into our system because work is 0 now. So you can see right here I put the spring potential energy is 1/2 times K times stretch squared. Delta T I left as 1 divided by 210. The total time is 9.4. So you can see that I put this all the same thing we did last time. I put everything back in, but the only thing I really changed was that I added the spring potential energy, and I calculated the change in the spring potential energy right here. So you can see that I plot, I'm going to run this. So you can see that I plotted this with T, and then where you're going to have the ball of the computational model, and then versus the ball showing from tracker information. So you can see it's running right now, and then I'm going to have printed the change in the spring potential energy right here. So you can see that in this graph they are being compared right now, and they pretty much line up all the way, and then all of a sudden at the very end they're kind of getting different. And yeah, and so this kind of shows how the actual mass moves. Looking at my what if questions, my other ones, my first one was, what does it mean? Compare the period of oscillation you found from examining the x component position with the period of oscillation term from the y component position. I found that they are the same because I looked at the number of oscillations and I divide that by the total time. By looking at tracker, you can see that the total time is 9.4, and if I look in the x, there's 6 oscillations, and then if I look in the y, there are 6 oscillations as well. So the period is not going to change, rather it is going to stay the same at 6 divided by 9.4, which is 0.64. For my third what if question, what does it mean question, I said, how does changing the location of the origin change the physics of the system? As I changed it to the origin to the original length plus mass times gravity over K, it only affects the spring potential energy. since US uses the stretch, which changes depending on the original and changing lengths. US equals 1/2 K times S squared. So it depends on the stretch, which is going to continually change, which the origin affects. The total energy stays at 0 because only delta US affects it.